Hello, my fellow introverts. Stacy here, your programming and test automation expert. Today we're going to speak about function default arguments in Python. And in particular, we're going to take a look how you probably should not use them with mutable types. But I'm going to show you one particular case, and there might be multiple others, where you can actually benefit from this feature. But before we start, please don't forget to like the video and subscribe to our channel. Okay, so let's get on with it and start. Okay, so we will start with the concept of default arguments. So let me first of all show you what it is. So if we have a function, add to list, let's say, we'll call it that right away, and we'll have an item, and let's just return the item and call the function. Add to list, let's say 1. As you know, we will just get this value. What we can do, we can add a default value to this argument. So let's say by default it's 10, but we are setting it to 1. And if we run it, we will see the same result. If we don't, however, put any value here and just run it, then we will get 10. So you don't get any errors, you just get the default value specified here. So it works perfectly fine with mutable types, but with immutable types. But with mutable types, you might get into an issue. So let's extend our arguments and add a list of items argument. And let's assign it to an empty list. So we have an empty list as the default value. This way we can show that, for this list of items, we just want to get a list. So this is cool, and why shouldn't we do so? Let's, inside of this function, we can just append this item to the list of items and see what happens. So let's do a list of items, append item. And we will return the list of items just to see that it was actually effective. And let's put here a 1 as it was before and see what happens. Okay, so we have a list with only one element, which is 1. So let's maybe call it multiple times, as we might want to do this in our application, and we will just do 10, 11, something like that. Okay. And again, probably you are guessing that when we do something like this, you are going to receive a list with 1, a list with 10, a list with 11, nothing else, just those numbers that we give here, because, come on, we just append one item, which is item, which we append here to the list. So let's run it and see what happens. Okay. So what is actually happening is, in Python, if you define a function, then all of those default argument values that you defined here, they are also defined when you define the function. So when you call the function, it would be unexpected for Python to assume that you want to create this list each time. So basically it's being created at the very beginning, so you shouldn't expect that it's going to be created each time that you call a function. So this is why this is happening. So you are just referring to the one simple reference and you are just appending to it. So this is perfectly logical from Python's perspective. So I ran into this situation a couple of times, and in fact this example is very simple, but sometimes you might just not think about it. You might just specify that this is a list just for the future generations who will use this function to be able to see that, okay, here I need to pass a list. Just for some reason, you're not using typing in Python, but, maybe it's Python 2.7 or something. And you just specify, okay, here is a list. So this is wrong. This is wrong in such situation. there are examples where you can use it this way, and I will go into them in a moment, but in this particular situation this is very wrong to do so. So what you can do, you can actually, this is a good thing to do, you can just do none, and if list of items is none, then you say that list of items is a list. Okay, just like this, and then when you run it, you will see the expected result, actually, something that you would have expected. So I hope you understood this. Probably for some of you who already use Python, this is nothing new, but let's take a look where we can actually benefit from such situations. So let's see a more complicated example. Okay, so now what we're going to do is we're actually going to write some handler for a game, let's say. So our game, it's going to be some kind of a board game where you can move forward, you can move backward, and you can sprint, actually. And all of those actions allow you to move for a certain amount of steps. Forward, backward, and when you sprint, you just do a lot of steps, like you can move forward for 1000 steps or so. So to do so, we will just use functions. I will not remove this one. I will just revert it to be the way it was before, because we want to benefit from this. And we will just remove these sprints. And let's go ahead and define those functions. So we will have a def move forward. Okay, and steps. How many steps? Let's keep it empty for now. So we will do the same thing for move backwards. And we will def sprint. We will not receive any steps here. We will just say that it's going to be 1000 steps or so. Okay, so we have our functions, and what we now want to do is we actually want to have a history of movements. So you are going to call these functions in multiple situations in your games, or there's going to be some other logic for this, for example, like throwing this cube, or for example, I don't know, maybe some random situation, random card that appears and allows you to move forward for a certain amount of steps. So you can do whatever you want with them, but this is just this mechanic which allows you to move somewhere, forward or backward, or just to sprint. So what we want to have a history, because after the round, probably somebody would like to see a graph or some history, how did he or she move. And this is why we're going to modify our add to list function to keep the history. So what we're going to do, we're actually going to call it like a history of movements. Let's call it like this. And these things will stay the same for now, and we will just call it in move forward, backward, and sprint. So let's do so. So we will, if we move forward, we will put history of movements. Then we will do movement forward, steps 200, let's say. Oh no, sorry, we have defined steps, so we can just pass them. Steps. Let's copy these, and here we will just do backwards. And probably we can do something like minus steps, because if we move backward with such amount of steps, then we will just, reduce the amount of steps that we're taking. And for the sprint, we will do 1000. But actually, our game has another rule. You can only sprint if you moved backwards before. So basically, if you move forward, then you cannot sprint. You will just not sprint. So then we will need to somehow check whether we moved backward before. So let's put a comment here. Check if we moved backwards before. And just leave it for now. Let's try it out. Let's see what happens. So we will just do move forward, move forward. Let's say 200, move forward 200, move backwards. Backward 200 or maybe 300, let's say. And then we sprint. Sprint, and of course we don't pass anything here. And now what we can actually do, because this is not going to show us anything, because if we run it, let me show you, nothing is printed. So we need to somehow know what was actually happening. And this is where our history can be very beneficial. And we can also do it in one step and just be able to write all of the movements from the history, and also to serve the purpose of checking whether we moved backward before. Okay, so we are going to first of all go to the item and assign it to none. So we will have another default value for this argument, and we're going to say if item is not none, then we append, and otherwise we just don't append, and we just want to get the list of our items. Now what we can do, first of all, we can go to the sprint function, and actually in case we didn't move backward before, we just don't sprint. So we will do if history of movements from -1, because we need to get the last element, and we do movement equals backwards. If it was backward, then we move 1000 steps forward. And one thing I noticed that we have in history of movements here in move backward, we have just backward how much, but we need something like this. So let me quickly change it. So I will just copy this one and do like this, movement backward, steps how much. Alright, and if we have the movement backward, then we move forward 1000 steps, and else we just don't move anywhere, so we just stay at the same place. So steps is going to be 0, and here is going to be no move, or something like this. So let's run it, see what happens. Okay, and here is our history. So we have movement forward. Yeah, agreed. Then we should expect move backward 300 steps. Yes, agreed. And then we have movement forward and steps 1000 because we had a sprint. So we could do move forward again here and check whether it works. We can do multiple ones, let's say 1 here, and let's see what happens then. Okay, and we have 200, we have 300, then we have 1200, we have 1, and we have no move and step 0. So this is probably a very static example of how you can use it, but keep in mind that for state management, or for example when you want to record some history, this might be of use. This might be even of use in testing if you, for some reason, your tests are executing randomly and you just want to know which test was executed after which step, after which test, sorry, you can do this. Probably you could have already created a list somewhere and just append to it, but this is pretty much easy and a straightforward way of doing so. So in such situations you can actually benefit from such approach. But in other situations I don't advise using it, and please keep in mind that sometimes you might not notice it and it might be a troublesome situation for you. So this is it. This is all I have for today. So I'll see you in 1 week. Have a very happy coding and see you next time.